the cosine rule, which also applies both in right-angled and non-right-angled triangles, and you'll see its similarity to Pythagoras' theorem in a moment. The same triangle we used for the sine rule, where if we have side A here, angle A is opposite, and the C's are opposite each other and the B's are opposite each other, as we can see. For any triangle ABC, we can use the cosine rule. A squared is B squared plus C squared minus 2BC cos A. Now if you just for a moment ignore the 2BC cos A bit, A squared equals B squared plus C squared is Pythagoras' theorem. And if you try working out the cosine of 90 degrees on your calculator, you'll find it's 0. So basically, Pythagoras' theorem is just a case of the cosine rule that works in a right-angled triangle. We can rearrange it for finding angles as this, but don't worry too much about that because you can't really get this in a non-calculated paper. So therefore, you're going to be able to use solve or an E activity. So just continuing this sentence on, we can use the cosine rule to solve for unknown sides and angles. The cosine rule can be used to solve triangles if the following information is given: 3 sides, or 2 sides and the included angle. Now let's look at that from the table point of view. So ABC, ABC. Well, let's suppose we know 3 sides. So we know this, we know this, we know this. Then clearly we don't know a complete row of anything. We don't know any of the angles. So we can't use the sine rule. You need a complete row to use the sine rule, and that tells us you're using the cosine rule. 2 sides and the included angle. So we'll just look at an example of that. So ABC. So if we know, say, B and C, the included angle is the angle between those, which is A. So we'd then know this, but we'd know this, and we'd know this. So once again, no complete row. And clearly we could just go around the triangle and we know C and A, and then the included angle is B. So it doesn't matter which example we picked, it demonstrates for all of them. So when you get these situations, that's when you use the cosine rule.